Hello class, today we are going to talk about solving equations that have rational exponents. So these are things like x to the 2/3 power, and we're trying to figure out what x is. Step one, isolate the exponent if necessary. Isolate that term. Get that x to the 2/3 by itself. Get rid of anything that was being added or multiplied to it. Next, raise both sides of the equation to an exponent that will cancel out the exponent. So this is always going to be the reciprocal power. This is going to make the exponents go away, so we now only have a linear, quadratic, or polynomial equation. And then we're just going to solve that as we've done in the past. So we'll do a couple examples here. So here we have 2x raised to the 3/4 power plus 2 equals 10. And we need to solve for x. So step one, as always, write down the problem. Now what we need to do is we need to isolate this term that has the exponent in it. So that means this plus 2 has to go away. So we're going to subtract 2 from both sides. Now we have 2x to the 3/4 power equals 8. Now we need to raise both sides to some exponent that will cancel out the exponent we have. So we need to cancel out this 3/4. And so what we're going to do is we're going to raise both sides to the 4/3 power. So we're going to raise everything to the 4/3 power. And over here on the left, it just cancels out the exponent. And then here we just see what that is. Well, that's the cube root of 8, which is 2 to the 4th, so that's 16. So we now have 2x equals 16. Divide by 2, x equals 8. And there it is. Good idea to check it, because sometimes things don't work out very well. And so we have this. Just plug the 8 back in, and we see that, yes, indeed, 10 does equal 10. So it's good. It works. All right. So let's do one more. Here we have x plus 30 raised to the 1/2 power equals x. So here you notice we have x on both sides of the equation. All right. Now we don't have to isolate the exponent because it's already isolated. There's nothing else here. Everything's being raised to the 1/2 power. So we need to cancel out the 1/2. So we do that by raising it to the reciprocal of 1/2. So we're going to raise everything to the 2nd power, or we're going to square it, which gives me x plus 30 equals x squared. Now looking at this, hey, this is quadratic. It's got x squared. So we move that x plus 30 over, put this in standard form, set it equal to 0. That can factor pretty well. Set both factors equal to 0, and we solve those. So we end up with x equals 6 or x equals -5. Again, good idea to check this. In fact, anytime you come up with two answers, you need to check those because they don't always work. Right? Saw that in the last video. So we plug it in. Plug in 6, and 6 plus 30 is 36 to the 1/2 power is 6. 6 does equal 6. Plug in the -5, and -5 to the 1/2 power is, well, first -5 plus 30, so 25 to the 1/2 power equals -5. 1/2 power of that is +5 equals -5, and no, it doesn't. So again, we see these extraneous solutions. All right. So especially when you have two solutions, or if you have squares going on, you definitely want to check those to see if you have any extraneous solutions, because a lot of the times you will. So this solution doesn't work. Our only solution is the x equals 6. That's it. Okay, so we're going to do these. I would like you to pause the video, work these out, make sure you check your solutions, because some of these will be extraneous, some of them won't. And you don't know unless you check it. All right? So pause the video, work these out, then come back and we'll see how you did. All right, let's see how you did. So there are the answers. If you got these right, great, you're done. If not, let's see what's going on. Okay, so let's take a look at this first one. Number 8. We have 3x to the 1/3 power equals -3. Well, we don't have to isolate the power, so it's because it's already all by itself there. So we just raise everything to the 3rd, so we cube it all, which gives us 3x equals -27. Divide by 3, x equals -9. Plug this back in and check it. Well, 3 times negative 9 is negative 27, and the cube root of negative 27 is negative 3. So it works. Negative 3 does equal negative 3. So there it is. On the second one, let's take a look at this. Number 9. Again, we don't have to isolate the power because it's already all by itself. It doesn't have anything being added or multiplied to it outside here. So we can just take this, raise everything to the second power, the reciprocal of the exponent we're getting rid of. That gives us x plus 6 equals x squared. Set everything equal to 0. We have x squared minus x minus 6. Again, that will factor out fairly nicely. Set both factors equal to 0 and solve, and we end up with x equals 3 or x equals 2. We need to take those, plug those back in, see if they work. So here they're both being plugged back in. And we end up with, let's see, no good. We have 3 equals 3, that one works. So x equals 3 is good. But when we plug in 2, we end up with the square root of 8, or 2 root 2. And 2 square roots of 2 does not equal 2. So that one's no good. So the only one that works is the 3. For number 10, let's take a look what we have here. Write down our original problem. Again, the exponent's already isolated. We don't have to subtract anything here. Raise everything to the 4/3 power, right? Because it was to the 3/4, so we're going to raise it to the 4/3. That gives us x plus 2 equals 16. So x equals 14. We plug this back in, and we end up with 8 equal to 8, so that works, and x equals 14 is a valid solution. And that's it. This is really pretty simple stuff, not too bad. The only trick here is remember that to plug in those solutions, make sure they really do work. Sometimes they work out, sometimes only one of them works out, sometimes none of them work. So you always need to plug these in, make sure they really do check out. Hopefully that helps, and I will see you next time.